All right, good afternoon, everyone. So thank you for coming today. So my plan today is to at least go over your practice test number one solution. If you haven't really tried it out, I would suggest maybe you should really try it. But it doesn't hurt to maybe hear some tips and also some walkthrough of the solution. For your lab number two solution. We already spoke about it in detail about the three axiom, for the celebrity number zero. Let me show to you there's something more I posted from Friday. I'll show it to you. So if you go to the lecture site, you will see that at the end, over here, there is something about lab two solution walkthrough. So that was a previous recording I did, also for the same lab. So if you want to go through not just the axioms, but also see how to visualize about the two remove events for your Celebrity One machine, you can feel free to go over that tutorial and look through the notes and let me know if you got any questions. So I think today we got about 1 hour, so maybe we should dedicate the time. I'm thinking we should really mainly do practice test one solution because that one really share the same format as your programming test one. And lab one solution, I do have a 1 or 2 points that I can mention briefly. Not much to say. And also if you got any time left, you can also ask me some questions related to your math review lecture because it's also important, for your understanding. But just remember, for your programming test one, even though you will be given the event B summary toolkit event B summary PDF that I'm going to provide to you, as you can see from your programming test one guide. But you should really also get yourself familiar with all the various ASCII syntax for the mathematical construct. So make sure whatever that appears on the paper or on the slides, sometimes they may appear slightly differently when you type on the ASCII sign, right, on the rodent. So that's something you want to be sure you know how to do it. All right, so now, okay, approve for, okay, if you want to record on your computer, I think that should be fine too. I'm recording anyway. Okay. Okay, so let's now get started. So just before that, I already showed to you about your lab number two solution walkthrough, right? And let's now go over practice test one. All right. Maybe I'll discuss them maybe in pieces over here. So in the actual programming test, you will be given some informal description for the yeah, I'm gonna post the recording on the YouTube as usual, like a lecture. So if you guys have any other question, feel free to put on the chat. I'll try to monitor every once in a while. Okay. So the formats for your programming test one, you're gonna be given some informal description. It could be something like this. Sorry, let me just connect my iPad pencil. Give me just one moment. There we go. It could be something like this, right? It would just be e-description, right? It's something about the context. And also some more prescriptive steps that you're supposed to follow. We'll make that as explicit as possible in the actual test. But sometimes I might say, now for this particular constraint that's mentioned in the problem description, now I want you to formulate it in math. That might be something I would say, in the actual test. So it depends. But you already got some idea from attempting the practice test one. So let's now start with the context. That was rather straightforward. Okay. So we got axiom 1, 2, 3, 4. Oh, by the way, so in the actual test, you're not going to be given any rodent project to import, right? So let me just say this. In the actual test, no rodent project to import. Instead, you have to develop from scratch, like what you did in lab one and lab two. And you got to export the project as a zip file and for submission. That's basically what you got to do. Right? Just remember, you really want to review the steps about how to create the rodent project and also export it for submission, which you have done twice already so far. All right, so let's now take a quick look, and then after going through the axioms, I'll take a look at the chat. Okay. So now we're creating one context over here, not machine just yet, the static part for the problem. So axiom number one, we want to do something about a constant. Just remember, every time you define a constant or a variable, you should always accompany that with some associated typing constraint. Just remember. That's always the case. So whenever you got any constant or variable, and of course, the constant will belong to the context, whereas your variable will belong to the machine. Either case, you should always get some typing constraint. Right? Just remember. All right, let's now take a look. For axiom number one, so we want to do something with the constant cap, right? According to environment's constraint number 5, it's just an integer larger than 0. That one's easy, right? So how do we declare that constraint, right? We talk about natural number, right, in the course, in the class. So natural number, it will be starting from 0 and 1, etc. But we got another one, natural 1, so that'd be starting from 1, 2, and etc. So that's why here the correct choice should be M1 over here. So that would be a typing constraint. If you only did the following, let's say for axiom number 1, if you simply say the cap is larger than 0, this is not really a typing constraint. It is something that can be provable from the typing constraint, but itself by itself in isolation is not a typing constraint, right? Just remember. So this one here by itself is not a typing constraint. So if you simply put cap larger than 0 over here, that's not correct, right? All right, axiom number 2. We want to do something to do with limit, similar. A number of students the school can take, right? And in this case, if you go back to environment, so here, environment 6 over here. Okay, a school can accept up to limits students, right? And over here, the practice test doesn't really say explicitly that the number of students cannot be 0, right? In this case, because the answer apparently is using the positive number over here, right? But I would say in the actual test, we'll try to be more explicit. But for the practice test, we can leave in a little bit modeling decision for you. But I would say here, you should really think about if you're accepting some students, how can that be empty, right? Maybe the school will start to be empty, but when you start accepting students, that should be a natural, like a positive number over here. All right. All right. So axiom number 3. So we got carrier set. So this may be something new that you haven't really seen in the previous 2 labs, but now it's time to know. In rodent, you can actually say something like, if I got carrier set, for example, the students, you can see this is one of the carrier set. We say that should be a finite set of students, basically, right? It's an abstract concept. We don't really know exactly how many, but at least we know it's finite. Okay. So that's what you do. It's a finite over here, right? You just say finite, and then you just put some carrier set inside in rodent, and this is to say that one there only got finite number of elements or members in the set. So that may be something new to you, but now you know. Right, so similarly, we got axiom number 4. We got another carrier set, which would be the finite set of students, right? In that way, we just say, okay, courses first, and then the students, right? Course first, and then also we got students. You basically just follow through one by one, right? Instruction, one step at a time, okay? And when you actually do the actual test, make sure you also type in the name of the axiom or invariance or variable or constant, right? All those things. Whenever the names are given to you, you really want to make sure you type them verbatim. So when the TA checks, they will actually also check the names as well. All right. So that's why when you type, these should also correspond to what are given to you in the instruction. All right. Right. So that's about the context. Okay. I do have some question here. Billy, go ahead.
Okay, so could you, I don't know if you have already explained this, but could you explain what is carrier set mean? Like,
Carrier set.
we
Okay.
know what a set is. Yeah,
Sure.
yeah.
Sure. No problem. So think about the carrier set. It's basically, apparently it's a set So we say it's a set of certain, okay, let me say this, a set of certain kind of entities of the same kind, of course. For example, we might say a set of students and a set of courses. And we say that every carrier set you define, they don't really overlap. Okay, so number one is all carriers, no two carrier sets overlap. They're separate. No two carrier set because they're different kind. So for example, you see the student here and the course here, they're two different carrier sets, so they don't really overlap on their members. You cannot say a student is equal to a course, right? It doesn't make real sense. So two carrier sets over here of different kinds. And another point over here to mention is there is no need to further specify the set's contents. So this is what I mean. So once you declare students and course, you can already use them. Like for example, you can see the student here and the course here. And once we go to the machine part about defining variable, you can also say maybe some function is going to go from students into course, right? You can already use a carrier set. And sometimes you may also find it useful to also specify certain member. For example, you can say, let's say I got students over here, right? So another way to do this, I'll just set it here. I can add potentially another constant. Let's say we want some constant course. Let's call it EECS 3342. I can say EECS 3342. I can declare one extra constant over here under constant. And we say that as soon as you define a constant, you should also specify its type. We need a typing constraint. And now the typing constraint will be EECS under the axiom 3342. You can say it is a member of the course carrier set. So this is something you can also do for the carrier set. So you don't really have to say what's everything that's actually in 3342. We don't really need to. But if you want to be specific about certain members in the carrier set, you can do that. All right. So that's basically what a carrier set is.
Okay, perfect. Thank you.
Okay, good. All right. So let me look at the chat quickly. Okay, so any private questions sent to me, maybe I'll delay them a little bit later, right? I'll just look at the public one that's sent to everybody. Can we see carrier sets different objects? Yeah, you can think about, no two carrier set overlap, right? So they're just like a different sets of different kinds of entities. Yeah, so the programming test is going to share the same format as the practice test. And I would suggest you guys to also review what's laid out in the programming test one guide. That one also explain about what you can expect. Okay. All right. Any follow-up question to the context? Anyone? All right. If no, let me move on. Okay. So we are done with the static part. Let's now move to the dynamic part, which will contain variables, invariants, and also events. All right, let's talk about invariance first. So what you can think about invariance can usually there are two purposes of the invariance. I think that's something we also learned from lab number one. Let's recap, let's review. Okay. Usually invariants are for two purposes. It could be the typing constraint, specifying the types for variables, not for constant. Constant belong to the context, which we have done already. For variables. Or number two, it could be some properties that we want to specify for the variables. In addition to typing constraint. Typing constraint is a must, is required. But usually to really make your model as rich as possible and also as accurate as possible to reflect what you really want to solve, you want to also add additional properties as invariance. And properties may involving both the constants. Sometimes you may want to refer to the constant and specifically variables. So these are the two main purposes for invariance. Okay. For example, you can see that this invariant over here is typing constraint because you're specifying the type for C. And these two are more like properties. They might be there to, for example, reflect certain requirements, which we'll see, right? All right, so now let's take a look. Invariant number one, we want to have a relation C, right? As soon as you see that, it already tells you what you may want to do, all right? As soon as I see this, I may just sketch in my mind. May not be the final answer, but maybe I can sketch right away. Okay, let me just say this. It's a relation, a single relation, right? So that means C will be a member of certain relation, right? As soon as I read that line. And of course, as I read further, I will see which these two sets should be. I would say define as students can take a set of courses. Now here, we got to be more careful. Students, first of all, and also each student can take a set of courses. So this is how we interpret this particular sentence here. So we say that the relation should really be mapping from students into set of courses. All right. So here we should really put the carrier set that we defined earlier. Remember what I said earlier. So once you define the carrier set, you can refer to it whenever you need some type. So students is one of them, right? Remember we got student. Oh, should be all capital. Let me be consistent. So students is one. All right. And here we say that each student does not only take a single course, but you will take a set of courses. So now if you simply say course over here, it's not right. All right, so this could be some confusion here, right? Let me just write it out. So when you say C it's more like a modeling decision you have to make. If you say C is a member of, let's say, students, and then I'd say relation, oh, let me say it again here. And let's read a bit further. This one is important. Map students in a school to a set of courses. Okay. So maps over here is really important. Okay. Whenever you see maps, it should be either a relation or a function. All right. So here we are saying that each student should be mapped. Is map to a set of courses. This is what's said in the question itself. So now we have a modeling decision to make. This could be one. We're simply saying C is a relation between student and course. All right. Another one, we got the solution over here. And do you guys remember what this is? That's something we covered last Thursday, right, in the class. So this is a partial function. Right? You should really review what it is. Right? So let's compare these two. Partial function, and then we say a set of courses over here. Now we want to really have you understand number one and number two, right? Number one is actually not correct. It's getting there, but it's not exactly correct. Number two will be the best answer for this one here. All right. Can anybody tell me why number one would not be a good enough answer? Or let me give you a hint. I'll write it down. It's important for you to understand this. So if you look at the right-hand side, right, we talk about what this really means, right? In class, you should really review that part of the lecture. Can this allow any relation? Yeah, if you remember, this one will be a set of all possible relations. So can this set here contains any member that's going to violate this particular requirement, which says that students should really be mapped to a set of courses. Let's say Jackie doesn't just take a single course. Jackie may take 3342 and 2030 at the same time, right? It should be a set of courses. Allow any relation that violates the requirements. And by the requirements, I really meant the requirements over here, right? That will be the hints for you. Something about the cap, not really, nothing to do with the cap. You want to think more about what kind of order pairs are we storing in the relation versus what kind of order pair do we store in this particular function. But of course, function is also relation, right? So these will be the two things I would say you want to take away from practice test one of the important things. Anyone would like to give it a try? It's okay to be wrong, but at least we can have some try to see why you might think this one should not be appropriate to be the answer. Anyone? If no, I can tell you the answer, but the first one over here gives pair, I agree. Okay, how about this? Why don't we try a little bit more? For number one there, what could be some example relation? Let me just go back here. For number one, some example could be, let's say I have a relation order pair. So for example, let me just put myself, let's say Jackie here, and then EECS 2030. And also maybe Jackie here, EECS 3342. Let's say, right? So this one here satisfies the requirement, right? You can see the same students is taking a set of courses, right? So you can see the fact that the same domain value is mapped to two different values over here. That's okay. It's a relation. It's not a function, right? So this one is okay. I'll give you another example here for number two. How do we express the similar concept over here, but to say it's a function and into a set of courses, right? So now it would be for Jackie here, the same domain value, but now it's going to map to a set of courses. In this case, the second value here is also a set. So it's going to be EECS 2030 and also EECS 3342. Right? You can see that this entire thing over here is a set of courses being the second value in the pair. Being the second value in the order pair. All right, so far we talk about example one for this, example two for this. They both represent properly about the same students taking a set of courses, right? However, I would still say this is wrong. But why? All right, so here's the answer. So question for you. If I simply got a relation here, let me say R here. Let's say R is this, I'll simply take out one pair. Oh, you know what? Sorry, maybe not R, maybe C, since I said C over there, right? So now for one here, right, I say C should be a member of the relation between student and course. Do you think C over here is valid? if I say this student here is taking only one course, would that be considered a relation as far as the type is concerned? You'll be okay, right? Because it's a relation, it's a set of ordered pairs. In that way, you can easily allow just one over here, one pair, which with the students taking only one course. So that's not as good unless you put some extra constraint. So if you only put this one here, in some way that's not restrictive enough. But if you put this one over here, it's going to make sure every student, they are going to be mapped to a set of courses. Of course, this set over here may be small, maybe big, but at least conceptually, it's more accurate and closer to what the requirement is saying. All right. That's something you guys will have to think about a little bit more. All right. So the C here is a relation, but not accurate for the requirements, which is over here. Okay. Do you guys have any follow-up to this in variant number 1? I think that's the more important one to really understand. You really want to understand why the answer should be this one here as opposed to just this.
Professor, what's the difference in using the maplet function?
You mean what's the difference between this and this?
No, the maplet function that we were using in
You
lab
mean this
2.
one here? The
Um,
partial function? Is that what you're saying?
Not a partial function, Prof. In our lab 2, we were using a maplet function from Rodin, which was mapping the celebrities.
Lab 2, okay, you're jumping ahead. So okay, I can jump ahead a little bit. So lab 2, which function are you talking about? So I can go to lab 2 right now. Are you more talking about this one here? That's a
No,
relation.
not this one.
This one.
Yes, Prof. Yeah,
Mm, what
that would make
are you
sense.
talking about a celebrity 1 or celebrity 0? Oh, that's a
Celebrity,
maplet. I see.
yeah, maplet, yeah.
Yeah, the maplet. Okay, sure. The maplet here is actually for order pair. So in Rodent, oh, let me just see. Let me just find one example for you in the if I have one in the lab 1. Give me just one moment. Deposit and also transfer over here. Oh, there we go. Okay. So the question you just asked, okay, good. The symbol over here is a maplet function. That's maplet. Okay. So it's basically when you say A maps to B. So this will be what you have to do in Rodin. You can see from the lab number 1 solution, right? Because now we're updating the balance function. On the other hand, if on the paper you got to say A comma B, you can say this too, but I think on the paper we can just stick to our convention from the lecture. So this will be on the paper. But when you actually did in the programming test, you want to make sure you understand this notation here, right? That's kind of covered in lab 1.
Yes.
Chen, go ahead.
Um, Professor, I have a question about the relation sign.
Sure, relation sign. Okay, so
So
okay,
yeah, yeah,
maplet. I presume everybody
yeah.
got the point. Okay, relation. From the practice test or from somewhere?
On the practice test
Okay, this
machine,
one here. Go ahead.
yeah, invariant pattern.
Mm-hmm.
So on the syntax document you provided on the lab
Yeah.
document, so it says the relation is a set of ordered pair of many-to-many mapping. So I still gonna get why this restrict the students to take on only one course.
Oh, you wouldn't restrict always. I'm just saying
Uh,
the way.
okay.
Okay, good question here. So when I say C here, oh, how about this? When I give the example for this relation here, the relation could be, let's say this one here, where Jackie is taking 2 courses. That one is allowed for sure. But it also allows the possibility where the students is only taking one course easily because in the relation, there's nothing about really domain value, which is going to map to like a set of values. It's only mapped to a single value. But if you really want to get all the values being mapped from domain, you have to do further things about the relational image. You can do that, but it will just be some extra constraint you have to specify. On the other hand, if we specify this one up front, we know that for every domain value over here is going to map to this particular set. So that one is corresponding more closely to what the requirement is saying, because each student should really be enrolled to a set of courses.
I got it. Thank you.
Yes. All right. Good. All right, guys. Any other questions? All right. I mean, just see if I missed anything. Yeah, if there's anything that's not clear, feel free to follow up. I think we'll just go as much as possible. Okay. What is the difference between maplet versus partial function? Yeah, partial function it's a kind of relation, right? It's a set of pairs. But if you say maplet, like this guy here, is only a single element in a relation, right? For example, like an order pair, right? For example, A maps to B. You might say it belongs to the nose function, right? It's different. Will I have another Q&A session before the test? I still got office hour. I think tomorrow over Zoom, 3 p.m. And also Tuesday, 3 p.m. I still got Q&A over there. But it might be just you gotta drop by, my office hour, either Zoom or in person. But to really like a walkthrough like this, I'm afraid today will be the only one. Yeah. But it could be to advantage as well. For Monday and Tuesday, just drop by. If you got a specific question, we can go over too. Okay, so let's now move on. Okay, we talked about this one here already. I think that's really the main construct I would like to talk about. So you guys will really want to make sure you review the math lecture to really make sure you understand the difference between this and this one here. All right. And the other two will be very similar. I would say the invariance number 3 and invariant number 4, they are somehow very similar to what you had to specify about the credit limits or the balance upper bound for your lab number 1, right? Similar. Okay, so similar to credit limits in lab number 1. So we don't need to spend too much time on that. But I can go over one of them very quickly. One thing to say, if you recall what we said on Thursday's lecture, we talk about well-definedness for function application. This is just another example. You can see this one here, right? C of A. Remember, C over here is defined to be a function, declared to be a function. So now this is a function application. And I will suggest you also review something about relational image, right? We talk about the difference between them, right? So you may want to review that too. So let's go back to this function application. Whenever we got a function application over here, in order for this application to be well-defined, the value over here you're trying to apply to should be in the domain of the function. If there's no way for the rodent to know, he's going to complain. He will say some obligation is not proved. Okay, so now for well-definedness, it's going to be A should be in the domain of the C, right? So that's why you see exactly the antecedents over here is there. So this is really to make sure this the consequence over here after the implication is well defined. So now you can see a little bit, appreciate a little bit more why we need that kind of antecedents. Right, so antecedent here is really to do with well-definedness. All right, that's something I'd like you to also observe as well. Right, so also we talk about the cardinality of the students. It should be less than or equal to some limits. We can only accept only up to certain upper bound of the students, right? Okay, let's take a look. For invariant number 4, you were suggesting something like that. Okay, good. Okay, I think it's a good question here. Why don't I put it on the page over here? Let me put a star here. So here for star, alternative, can we say the cardinality of students? I like this question. I'm glad you asked. Less than or equal to the limits. Okay, great. Number one, not correct. Okay. And number two, it really has to do with the interpretation of the students. So when you think about the carrier set students over here, all right, so let's now understand its interpretation. The interpretation should be it's the set of all possible students. And the rodent wouldn't allow you to inquire its cardinality because we don't know exactly. If you remember what I meant, what I said earlier, for the carrier set, no need to further specify the set's contents. So rodent has no way to really know exactly how many elements are there. They don't know. So you cannot say its cardinality. And also you cannot really remove something or add something to the carrier set. Let me just add here. Cannot add or remove to and from the carrier set. All right. That's the set of all possible students. On the other hand, so this is one thing you want to compare. Student carrier set is set of all possible students, in which case we don't really know what are the exact contents for this carrier set. It's only declare over there for us to do typing. On the other hand, when you say the domain of C over here is the currently enrolled students, the current student that have been admitted. So it's different conceptually. The domain of C over here, the currently admitted students. And because it's the domain of C and C is a variable, so that means this cardinality may grow or shrink. As opposed to the carrier set, the rule is you cannot grow or shrink the carrier set. So they're different. So what you suggested there, conceptually, I can see where you're going, but that's not right. Okay. May grow or shrink. So that's why in the events, you will see that when we try to admit or try to drop a student from the school, we only update the variable C. We don't really update this carrier set students because you cannot do it. It's a rule. All right, good. It's a good question. I'm glad I can clarify this today. All right, so let me know, guys, any follow-up to this, to the invariance? Again, I think that the most important thing for you to think through today, you still got some days to ask me questions, if you want to, maybe during the office hour, will be to distinguish between these two. All right. Okay, let's move on. We got events, we got admission, leave, and also we got enroll and drop. I think all of them are pretty straightforward pretty much straightforward. Why don't I just spend another 5 minutes? I'll go over one of them maybe in detail and then point out something that you should also watch out for. And then you can look at the solution yourself. If you want to ask any follow-up, you can let me know. So I can leave some time maybe for other general questions. If you got any confusion about certain concept, I can also clarify. So we can make use of the time. All right, let's now take a look. Initialization. Okay, and this one here, pretty easy, just empty set to begin with. So that means in the beginning, the school is simply just empty. All right. And why don't we take a look at just one of them? Let's say admission. Right. So for others, it will be very similar. All right. Let's now take a look. And I just noticed one thing here. You really also want to make sure you review the math review lecture. For example, this guy here versus this guy here. Would you guys want to type on the chat and tell me, are they the same thing or they're different? If they're different, what are they? Just look at these two. What kind of relational operators are they? For this one here and this one here. Looks similar, but they are not the same. Override and domain subtraction. Awesome. Very good. Okay. So you want to make sure you understand. Of course, now you're looking at the solution. I'm just asking you to tell me what they are. In the actual test, you will have to decide which one to use. All right. Okay, good. This is override. This is override, and this is domain subtraction. All right. Very good. All right. So let me now undo. Let's now go over just one of them together. Okay. Let's say admission. All right, for admission, we want to say, number one, the parameter S, students, it should be a students. This will be the type. And then you can see here, we got another, we got to say, if you want to admit some students into the school, they better not be admitted already, right? That's why you say it's not in the domain of C, right? So that means not already admitted, right? You can see the comments there. It says exactly that. Isn't already admitted. All right. And then, guard number 2 is interesting. All right. This is very important. All right. So this one is saying that since you're actually going to, so now you want to watch out for this particular sign over here. This has to, let me say this. If you look at action here, the action here, you can see we are trying to substitute the variable C by something else. That's the overall picture. So C is being changed. Variable C is changed. So what does that mean? That means any invariance involving C should be preserved. That's what the rodent will try to prove. All the invariants involving C will be, how about it must be preserved, because invariance should always be preserved before and after the events. Must be preserved. Right? And let's now take a quick look on what invariants actually involve the variable C. Let's take a look. Right? You can see here, this one just typing constraint, right? And this one specifically is what that one is talking about, right? To say the cardinality of the domain of C should be less than or equal to limit. And let's now copy this invariant here, invariant number 4. All right, let's now go there. So this one is relevant to invariance number 4, which is about the domain of C is less than or equal to the limit. All right. So now intuitively, why are we turning this less than or equal to into less, right? You can think about it's like this. If I tell you that for example, let's say if let's say for example, it'll be easier for you to understand. Let's say for example, let's say the limits is equal to, let's say 100, maximum 100 students to be admitted to the school, let's say. And the invariance says that the domain of C should be less than or equal to 100. That makes sense, okay? And we know that for this particular admission events, it's going to overriding S into empty course. So this is to say student S initially is going to take a set of courses, but the set is simply empty. They are just newly admitted, maybe in their first year. All right. And we say that S over here should not be already in the domain of the C function. So that means it will be a new pair that we're adding to the function, right? So we know that this C over here will be extended by one pair. By one pair after the admission. Right? So now what we want to say is, what kind of guard should we put to make sure after this extension, we can still satisfy this particular invariance, right? So now you want to think about, the way to think about this would be, if you put it here, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, 1 + 1 = 1, This will be the invariance before emission. And what about the invariance after emission? After emission, we still want the domain of C to be less than or equal to 100. However, right now, the C here is no longer the C before the events. It's being extended with one pair, right? You can think about it's like a C. Let me say a little bit more informally. Extended with one pair, right? So the important thing for you to notice is this C over here before the emission. If you compare that with the C after the emission, the difference is after that, we got one extra pair. So this is something called pre-state and post-state. That's something we'll talk about once we get to the case study. But for now, you just need to understand that intuitively. All right. So that's why you want to make sure after this extension here, it will still be less than or equal to 100. So that's why in order to really make this work, you have to turn that less than or equal to into less than over here. So this less than here is to make sure that after the extension less than or equal to, which is what the invariant is insisting, should still hold. All right. For example, in this case, it should be the domain of C should be less than 100. That means you can have only maximum 99 students before the admission, because after admitting another one, you'll get to 100, reaching the maximum. All right. Can we do union instead of overriding here? Yeah, that's right. That's fine. If you do union, that should be okay. But I can give a try too in Rodin. All right, so we just walked through one event in detail. So what you guys want to really think about when you go over the remaining three events, I would suggest the following. Whenever you look at the guards, they should be either about the typing constraint or something that's going to correspond to the requirements, or that's something that has to make sure the corresponding invariant should really be preserved, right? So these are the three guards that kind of exemplify the different purposes. And then whenever you think about the action over there, you should want to think about what kind of relational operator you're going to use. Okay. All right. Any follow up to this? Yeah, something about option. I think for the relational overriding, it seems to be an issue for the current version of the Rodin. When you actually type in the less than plus in Rodin, somehow it shows the option. I agree. But just make sure whenever you use overriding, you really type in whatever you're supposed to type. And then if it really shows option, you might be just okay. It's just about the display put by the Rodin. All right. All right, guys. Any follow up to this? Okay, there's one more thing I want to say about relational overriding. So I think that will be what I want to speak about for practice one. You can feel free to go over other events or what we spoke about today. Ask me follow up during the office hour, and then more than happy to talk about. I want to say one more thing before I can maybe take some other questions if you may have, maybe about a lecture or maybe something you want to ask. If you go back to lab one solution, one thing that I think you guys might be more confused about is about transfer events over here, right? We got guards over here. They're rather easy to understand at this point. If you look at this one here, right? So now we are doing overriding again. So this is overriding again. And we are saying that we want to make some changes. We want to make some changes to the balance function. We basically want to keep the same balance function B, but we want to make the following two changes. Now, A1 should be transferred into A2. right? So that's why you see the maplet function over here. So think about what's happening is this. So when we talk about transfer, right? Let's say what we want to do is we want to somehow model what's going to be the consequence of the events transfer happening. So this is what you can think about. Let's say the transfer happening, and we got something called pre and post. Pre is like before the transfer occur, and post is like after it occurs. In the pre, we got the B function, balance function there. You got various pair. One of them would be A1 maps to its own balance. And also A2 maps to its own balance. This is before the transfer happened, right? What about after? After that, you're going to get everything basically the same. Anything that's not really to do with A1 and A2, they should remain the same. So that's why overriding will be the best option, because overriding really tells you what's really the modeling concept to say the relationship remain mostly the same except certain changes. Okay. And then everything else remain the same except, so now for A1, it should now be mapped to its old balance over here, and then minus the amount to be transferred. And also A2, it should map to its old value, the old balance, and plus the V. So you can think about these are the only two pairs impacted by the transfer function. So that's why overriding operator will be the best choice. Union would not be as good. So Rodin might complain there will be some proof obligation that cannot be discharged right away by union. So maybe back to your earlier question there about this one here. If you think about the modeling choice over here, right, this one here. So here, maybe overriding is also a better choice because we're saying this. We want the C function here after the emission to remain pretty much just the same, except one change that's really specified in this singleton set to say the only thing I want to change on the C will be I want students S to be mapped to a set of courses, like an empty set, right? So you should really try to see which one is going to make Rodin happier, right? Rodin might be able to simply discharge either union or overriding. But if he's only able to discharge this one here rather than union, then you should really stick to this overriding, right? You do have choices there, but you got to experiment yourself. All right. All right, I think we got about 5 minutes, but I'm okay to maybe go beyond a little bit after 6. But do you guys have any follow-up question? Not just to the solution here, but if you got any question about the math lecture, feel free to ask. I can answer too. Yeah, recording, I'll try to make it available. I got another review session for my 2030 students at 7. I will try to maybe make it available later tonight or early tomorrow morning. I'll try. Will we still get part marks if at the end of the lab test Rodin shows errors? You might get some part marks, but I think getting syntax error would definitely get some penalty because you're not supposed to get any syntax error, right? You should really make sure everything you specify for the variable, for the constant, their types, and also all the property, they should be in valid mathematical form. On the other hand, if maybe if the test say you must pass certain proof obligation, for example, but you didn't pass, you can still get some partial marks for sure. It depends on the situation. Yeah. Something about the B for lab 1. Let's see here. Let's now review. For lab number 1, if you look at that, the balance. No, it's not a relation, right? B here is a balance function, partial function, right? It's going to go from account into integer. And at this point, you should really also think to yourself for this one here. I'll put it here. Alternative. Guys, answer this question here. That will be good exercise for you. What if I say B is a relation between a count and integer as opposed to partial function. Is the alternative correct or not? And why? So now this is part of your lab one. I'm suggesting something different here for the balance function. Would it be okay to say this? Anyone? You can type, you can speak up. Okay, no, since not all B will be mapped in relation, not quite. Not quite. No, because we can have accounts that are not active, also not right. All right, good try, but not right. You want to think about what's the fundamental difference between function and also relation. I'm hoping that somebody can tell me the right answer. It's really the difference between function and relation. It's something to do, also relevant to the modeling exercise that we did on Thursday. All right, so B can be mapped to more than one. Okay, I think that sounds more right. All right, so here is a relation, right? So that means an account may be mapped to more than one. Values for the balances. For example, we might say the balance function could be something like, right? Let's say part of it is, let's say A1 maps to 23, let's say, for example. And also we got another A1 that also maps to 46. And this one doesn't make sense. How can a single account map to two different values? That's definitely inconsistent, right? So that was wrong. On the other hand, if you got function, right? The functional property, that's something we spoke about in the class. So this means every account can only be mapped to at most one value, right? You got to be very clear about the consequence of choosing either this, or something that we also talk about in the class, right? And don't forget, as I mentioned on Thursday's class, even though we're only going to review the injective and surjective function on Tuesday, but the slides have been there since uh, many weeks ago. So you should really also study ahead about the injective or surjective function. They follow a very similar pattern, but you gotta know what they are. But we're gonna talk about some example on Tuesday too. But you should really study ahead to really get it straight. They might be relevant to the programming test one too. Okay, so that's something I want to mention about lab one. Any other questions? Anyone? Do we have to discharge all the proof obligation in the programming test? That's something you have to depend on the instruction. If the instruction doesn't really say that you're supposed to get all the green, like everything discharged, then you just do your best, right? So maybe even if you got some maybe proof obligation undischarged, that's something we have to look at your answer, manually to see if they really make some logical sense. On the other hand, if we say explicitly that you're supposed to put in the construct that's gonna make everything totally discharged, yes, then you have to. So it depends on how the instruction phrase it. All right, sounds good. But the format for the actual test, you can expect that to be very similar to your practice test. The level of difficulty could be higher. So I think you definitely want to go over practice test one if you haven't, and also go over your lab one, lab two. And for the mathematical construct, even though you will be given the summary PDF during the test, but you definitely want to know where to find information, so you wouldn't have to waste your time during the test. I think the PDF is only there if you really forget about something suddenly. In that case, you can refer to it. Otherwise, most of the commonly used stuff, they should be quite clear to you in your mind about how to use them. All right, guys, I don't mind staying longer if you guys have questions. If no, then that's okay too. I will pause for now, but you guys can feel free to have any follow-up if you want to. Okay, you guys are welcome. So I would say hopefully this will be useful to you, but guys, don't forget this one. I really hope to help you a bit, but you still got to study. All right. If you don't have any further questions, feel free to go back to whatever you got to do. Enjoy your Sunday. If you still want to ask me something, feel free. I can stay for 1 or 2 more minutes if you got questions. All right. All right. So if no further question, why don't we call it a day right now? But don't forget, I still got office hour Wednesday and Thursday. Sorry, Tuesday and Wednesday. Monday, Tuesday, and Thursday. All right. See you then. Take care. Bye-bye.